Okay, so this lesson is called reaction time, and it's going to focus on the state standard 823, identify and describe the particulate nature of matter, including physical and chemical interactions. And specifically, we're going to be looking at the difference between a chemical and a physical change. Now, I've put the lab coat on because this one can get messy, which means students are going to have a lot of fun with it. And we're going to be doing a couple of activities together, 2 demonstrations in your room, elephant toothpaste and CO2 balloons, and then each student is going to be making their own silly putty and trying to determine if the creation of silly putty is a chemical or a physical change. Now, the first part of the lesson will start with a discussion about the difference between a physical and a chemical change, because it's really important for students to understand. And occasionally, students have trouble with this. And so the biggest difference that students need to understand is that the product that you end up with in a physical change is the same thing as what you started with. You don't have anything new being created. There's no new substances being formed. Well, the exact opposite is true with a chemical change. When you have a chemical change, there is a new substance formed. Something that was not there before is now in front of you, in the beaker, or whatever you've done. So an example of a physical change would be ripping up a piece of paper. An example of a chemical change would be burning a piece of paper. Okay? There's signs that we look for when we think about a chemical change. Change of color, smoke or steam or bubbles being given off, change in temperature. Okay? Those are things that are really good indications that a chemical change has occurred. With a physical change, you're talking about mixtures of things. If you mix salt and pepper together, right, that's not a chemical change. You haven't created something new. And you could go backwards. You could separate those two things out, again, if you wanted to. So I'll go through several examples with students, asking them whether what I'm talking about is a chemical or a physical change. One example that students sometimes get caught up on is if you put sugar in water and stir that water until the sugar disappears, it dissolves, would that be a physical or a chemical change? And most students will say that it's a chemical change because I think it's because the sugar has disappeared, and so to them there's something new, something happening there. There's some new product, sugar water. But there are a few kids in the class that will understand that if you boiled the water, you could collect that water as steam. You'd still have the water, and the sugar would be left. So you can separate those two through a physical process of boiling. So the demonstrations, I wanted to show you what they are so you kind of knew what to expect. The first demonstration that I'll have your students do is called elephant toothpaste. And this is a safer version of elephant toothpaste. It's safe for the classroom. And I start with soap and some food coloring in a bottle, in a 20-ounce bottle. And then I have one student add a package of yeast. And so just dump that in there. Okay. And have them put it all in the bottle. Now this one can be really messy, so I like to make sure we have another container that the bottle's in. So we just have them kind of swirl it around. And have your volunteer helpers look in there and see if there's any signs of a chemical change. Any gas being released, any change of temperature, anything like that. Change of color, nothing yet. So then you're going to have them add hydrogen peroxide. And you want to put in a pretty good amount of this stuff. And what this does is it actually reacts with the yeast. Okay? And the yeast and the hydrogen peroxide react, and then they form bubbles in the soap that's in the bottle. And we should get a pretty good reaction going on. So I'd have the kids kind of really swirl it around a lot to get that reaction started. Okay. The one thing you don't want to have them do is put the lid on, because you can create a bomb that way. And so you can see then, all right, that you've got this reaction happening where you have foam coming out of this bottle. All right. And so now all of a sudden you can ask kids, all right, what are the signs that we have here of a chemical change? And there's gas being released in the form of bubbles. If they put their finger in the bottle, okay, they're actually going to feel that the temperature is increased. So there's been a change in temperature, which is another really good sign that a chemical change has occurred. And as you can see, this is a really fun experiment to do because you get so much foam out of this bottle. It just keeps coming and coming and coming. Alright, so we'll set that one aside. That's the elephant toothpaste. Then I'm going to do a simple demonstration here where I just take a torch and I melt an ice cube. It goes from a solid to a liquid, and then I ask students if that's a chemical or a physical change. And most of them will say that it's a physical change because you could go back to ice if you put the water in an ice cube tray and put it in the freezer. But then I ask them, if I continued to heat up that water until it turned to steam, would that be an example of a chemical or physical change? And almost all of them say that that's a chemical change because, again, it's something about the substance seeming to disappear that causes students to think that we're dealing with a chemical change. But the reality is, obviously, that water, liquid water, is just turning to gaseous water, steam. It's still water. We still have the same thing that we started with. It's just in a different state. And so it's important for kids to understand that when something changes state from solid to liquid to gas, it can always go back to from gas to liquid to solid. And so it's always a physical change when we're talking about a change of state. And then the last demonstration we'll do before we do our silly putty is I'll have a kid come up, and there's vinegar in this bottle, there's baking soda in the balloon, and we'll stretch the balloon over the top of the bottle. Okay. Get it on there pretty good and tight, and then have them dump the baking soda into the vinegar. Alright, and see what happens. Okay. And we should get a nice reaction here where the balloon actually fills up with carbon dioxide. And so again, you can ask them, how do we know that this is is this a chemical or physical change, and how do we know? And it is a chemical change because you've got this gas being given off. Alright, so you've got the balloon inflating. That gas is coming from somewhere, it's coming from the reaction. And this is actually an endothermic reaction, and if you feel the bottle, you can feel that the bottle actually gets a little bit colder. So the temperature changes in this one also. So two good signs, gas being given off and a change in temperature. Okay, so with those demonstrations done, then we'll move on to the final project, and that is actually having students make silly putty. Making the silly putty is just a fun way to end this lesson, thinking about chemical and physical changes. And the students are going to need to put in 1 tablespoon of glue, alright, into their little cups, a tablespoon of glue, and then I'm going to have them put a tablespoon of cornstarch, just kind of a heaping spoonful here, on top of the glue. Maybe it's just a tad more than that. And a pipette full, about 1 milliliter of borax. So you squirt that right on top of your mixture. And I'm going to add just a little bit more because mine didn't quite fill up. Okay. And then they let that sit for about a minute, and after a minute they're going to start to stir this around. And as they mix it around, they're trying to get all of that cornstarch incorporated into the glue. Okay. So mix it around and they're trying to smash it together. The more mixing they can do in the cup, the less mess this is going to make. So just mix and mash this around until it gets to be kind of one big, I always tell the kids, you're looking for kind of a gross, kind of a cottage cheese consistency. Something like this. Okay. And then they can take this out, and they have to take it in their hands at this point. So if you're worried about your desks, you might want to have some newspaper down. And then they're just going to work this stuff back and forth between their fingers and keep it, the really important thing is for them to keep it on their fingertips. If they get it all over their hands, they're going to have no silly putty. They're just going to end up with really messy fingers. So they just work this back and forth, and as they're doing this, the reaction, the chemical reaction between the glue and the borax is going to completion, and that cornstarch is getting incorporated into this brand new substance that we have. So this is definitely a chemical change, but we will ask the students about that and how they know it's a chemical change. This one doesn't have all the hallmarks of a chemical change. It doesn't have a gas being released or a change in temperature, but it definitely is a brand new kind of substance. Okay? And so you can see as you work with it, it gets a lot drier, a lot less sticky, and then you can start to slowly work stretching the edges. Okay? And you just want to stretch the edges out, and eventually, as you work with this stuff, it's going to get to be very, very much like the silly putty you buy in the store. And so kids will get to take this home, and you can push it down on stuff and pick up pictures and all the kinds of stuff silly putty does. Make it into a ball and it bounces. And so once they get this made, we'll just have them put it right back in this container and put a lid on it, and it's theirs to take home to think about the fact that this is a chemical change that's going on. Okay, so for some follow-ups to this lesson, to encourage kids to keep thinking about the difference between chemical and physical changes, I've got a bunch listed on the lesson plan just below this video. Some examples of like a physical change demo would be blowing bubbles, making bubbles that then pop, turning cream into butter, so having the kids take turns shaking a pint jar of cream until they end up with butter. And there's lots of chemical ones too, making toast even. Something as simple as making toast is an example of a chemical change, because there's a color change there. There was a heat applied and you get this burning, and so toast cannot go back to bread. Frying eggs, all kinds of different things, small things that you could start a class period with each day, a 2 or 3 minute demonstration, just to keep kids thinking about this difference between chemical and physical changes. Alright, so this one is a lot of fun. It's really messy. We need to remind kids that this stuff is a brand new substance. It's not water soluble, so it will clog the drains. So they need to make sure to get this off manually, not with soap and water. Just rub their fingers around and get as much of this glue off as possible, because if they put it all down the drains, you're going to have backed up drains. Alright, so have fun with this one, and I'll see you next time.